Hey everyone, welcome to another BTM screencast. Today we'll be going over Chapter 1, Residential Workplace Safety. So some of the objectives for this: demonstrate an understanding of the electrical hazards associated with electrical work, demonstrate an understanding of the purpose of the National Electrical Code, or NEC, demonstrate an understanding of the arrangement of the NEC, identify examples of rules from the NEC that apply to common residential electrical safety hazards. Demonstrate an understanding of the purpose of NFPA 70E, Standard for Electrical Safety in the Workplace. Identify common electrical hazards and how to avoid them on the job. Demonstrate an understanding of the purpose of the Occupational Safety and Health Administration, or OSHA. Cite specific OSHA provisions pertaining to various general and electrical safety hazards associated with residential wiring. List several safety features pertaining to general and electrical safety. Demonstrate an understanding of the personal protective equipment used by residential electricians. Demonstrate an understanding of safety data sheets, or SDS. Demonstrate an understanding of various classes of fires, the types of extinguishers used on them, and the fire triangle. Following safe wire practices will help keep you safe and prevent equipment and property from damage. Knowledge of both general safety and electrical safety is the most important safeguard against serious or fatal accidents on the job site. There are three general categories of electrical hazards that a residential electrician could be exposed to. These are electrical shock, arc flash, and arc blast. It's very important to understand these hazards and learn how to avoid them. Now, when you look at these going from electrical shock to arc flash to arc blast, these, while they're all bad, uh, they go from worse to even worse. We'll go over some conductors and insulators. So, conductors allow electricity to easily flow. So, anything that's able to effectively transmit electricity. Some examples are copper, aluminum, gold, or silver. Insulators, on the other hand, are poor conductors of electricity. Some examples of this are glass, rubber, plastic, and wood. As we mentioned before, electrical shock. It's considered the biggest safety hazard. Electricity flows along a circuit, and a circuit consists of a power source, a load, and conductors. So we can see here's your power source, and the current is flowing from the source to the load through the conductors. The human body can become a conductor and part of the electrical circuit. This is what you don't want to happen. So you can see from the power source, the current is flowing through from the source to the load, and if you become a conductor, that's when you get electrocuted. There's a relationship between current, voltage, and resistance. This relationship is called Ohm's law. This is where current equals the electrical force divided by the resistance. Current flow is measured in amperes or amps, indicated by the letter symbol I. Electrical force is measured in volts, and this is indicated by the letter symbol of V. Electrical resistance is measured in ohms, and the letter symbol indicating this is R. So the relationship can be expressed as I, which is amps, equals voltage divided by resistance. So as a quick example, 120 volts divided by 20 ohms equals 6 amps. Here's some resistance values for the human body. So you can see dry skin, the resistance is 100,000 to 500,000 ohms. Perspiring or sweaty hands is 1,000 ohms. And if you're in water and completely wet, you can see your resistance drops to 150 ohms. We'll look at the effect of current on the human body, and this is indicated in the table that's adjacent. So on this side, you can see your current flow, which is less than 1 milliamp, which is 0.001 amps. No sensation. 1 amp here, 1 milliamp here, which is right here, possibly a tingling sensation. So as this ramps up, you can see 1000 to 4300 milliamps. You can get heart convulsions, also known as ventricular fibrillation, paralysis of breathing, which usually means death. So as an example, an electrician is using a faulty 120 volt drill. It's a hot and humid day. The electrician is sweating heavily. According to table 1.1, the electrician's body resistance is approximately 1000 ohms. Using Ohm's law, we can figure out what the current is. So we have 120 volts divided by 1000 ohms. So the current equals 0.12 amps or 120 milliamps. According to the table we just looked at, this amount of current will cause a painful shock to the electrician's breathing may stop, and there will be severe muscle contractions and death is possible. So as little as 0.12 amps is enough to kill somebody. Arc flash. Arc flash is a dangerous condition associated with the possible release of energy caused by an electric arc. The area around the arc will have an extremely high temperature, which can be as high as 35,000 degrees Fahrenheit. Arc flash burn can occur. Electrical burn can also occur anytime an electrical current flows through bone or tissue. So again, if you become a conductor between the source and the load, these are things that can happen. An arc blast, which is extremely dangerous, is when an arc occurs. A blast causes molten metal to be thrown through the air and onto the skin or into the eyes. The speed of the molten metal is estimated at 700 miles per hour. This can cause a high pressure that can rupture eardrums and knock people off ladders and scaffolding. The National Electrical Code, or NEC. The Guide for Safe Practices and Procedures in the Electrical Field. It provides the minimum safety standards for electrical work. It's updated every 3 years to reflect the latest changes and trends in the electrical industry. It is published by the National Fire Protection Association, or NFPA. It is NFPA 70, National Electrical Code. And here's a quick look at how the NEC is organized. And you can look that over. Some examples of NEC rules for ground fault circuit interrupter protection of personnel, or GFCIs. Section 210.8a requires ground fault circuit interrupter protection at various locations in a dwelling. All 125 volt, 15 amp, and 20 amp receptacles installed in bathrooms shall have GFCI protection. All 125 volt, 15 amp, and 20 amp receptacles installed outside a dwelling unit shall have GFCI protection. All 125 volt, 15 amp, and 20 amp receptacles located to serve the kitchen countertop shall have GFCI protection. Reason for this is because they all come in contact. One of the codes that you need to follow is if you install an outlet within 6 feet of any water source, you need to install a GFCI. Arc fault circuit interrupter, or AFCI protection, is defined to protect from the effects of arc faults and to de-energize a circuit when an arc fault is detected. Section 210.12a requires arc fault circuit interrupter protection for 120 volt, 15 and 20 amp branch circuits supplying outlets and devices in almost all locations of a house. NFPA 70E standard for electrical safety in the workplace. The purpose of NFPA 70E is to provide a practical, safe working area for employees relative to the hazards arising from the use of electricity. It covers PPE when an electrical worker is exposed to an electrical hazard. An employer must provide an electrical safety program and safety training. So again, we know that it's dangerous to be working with this, but our goal is to reduce the amount of danger on our end. The Occupational Safety and Health Administration, or OSHA. The purpose of OSHA is to ensure safe and healthy working conditions on the job site by enforcing the standards developed under the OSHA Act of 1970. OSHA provides for research, information, education, and training in the field of occupational safety and health and for other purposes. Here's an example of OSHA. So a lockout tagout procedure. So OSHA 29 CFR parts 1910.333 and 1926.417, which I will ask you about, just kidding, outline requirements for locking out and tagging out the electrical source for the circuit or equipment on which you may be working. So if we have anything in the lab that doesn't work, and you will see that there are certain things that even if they do work, they are locked. You are not allowed to use them. You need explicit permission to use them. But if they are not working, it is required that they are taken out of commission and locked and tagged out. Personal protection equipment, defined by OSHA as equipment for the eyes, face, head, and extremities, protective clothing, respiratory devices, protective shields and barriers. OSHA requires electricians working where there is potential electrical hazard to wear PPE. PPE is not a choice for an electrician, it is a requirement. It goes for BTM too. Personal protection equipment continued. Safety glasses, goggles, or face shields must be worn anytime a hazard exists that can cause foreign objects to get in your eyes from the front or the sides. Head protection must be worn whenever there is potential for objects to fall from above, for bumps to your head, from objects fastened in place, or for accidental contact with electrical hazards. More PPE. Work boots or shoes with slip-resistant and puncture-proof soles. Safety shoes with non-metallic toe like Kevlar prevents crushed toes. Exposed metal of steel-toe shoes represents a safety hazard around energized equipment. Again, it's a conductor. An EH marking means the boots are approved for electrical work. And sometimes you'll see an EH, and other times you'll see ones that are like a little lightning bolt, depending where you go. Hand protection must be worn anytime your hands are exposed to a potential hazard. Hearing protection, such as earplugs or earmuffs, must be used in high noise areas. Again, if you can't speak with someone in a normal conversational tone at arm's length away, you need to wear hearing protection. In addition to using the proper PPE, wear long-sleeve cotton shirts and pants made of sturdy, comfortable material like denim. Wear clothing that fits closely to your body and that is not loose or flapping. Do not wear clothing with exposed zippers, buttons, or other metal fasteners. Remove rings, wristwatches, and any other metal jewelry before beginning work. Fall protection. OSHA requires fall protection whenever workers are walking or work surface that is 6 feet or higher and has unprotected sides. The type of fall protection is usually chosen by your supervisor and include things such as guardrails, personal fall arrest systems, or safety nets. So for us in BTM, if we are working above 6 feet, we do have harnesses that you wear with lanyards, and we'll go over that as it's needed. When working at a residential construction site, follow these fall protection tips. Identify all potential tripping and fall hazards. Practice good housekeeping. Always keep stuff clean. Look for unprotected floor openings, floor edges, skylight openings, stairwell openings, roof and roof edges. Inspect fall protection equipment for any defects. So before you use it, you want to make sure that it's in good working order. Select where and use fall protection equipment that is appropriate for the job you are doing. Read all warnings and instructions before using any fall protection equipment. General safety rules. Plan your work properly. Choose the proper material and the right tools to do the work. Be serious about your work and never fool around on the job. Never use intoxicating drugs or alcohol on the job. Do not talk unnecessarily when working. Practice safe work practices. Exercise good judgment in both giving and receiving instructions. Material handling. Learn the correct way to lift. Get solid footing. Stand close to the load. Bend your knees. Lift with your legs, not your back. Never get on or off moving equipment. When two or more people are carrying long objects such as ladders, each person carries it on the same shoulder. Use hand lines to raise or lower materials and tools from scaffolding or staging. Ladders. Do not use metal ladders near energized lines or equipment. Inspect all ladders before using them. Always place a straight or extension ladder at the proper angle. Ladder should extend at least 3 feet above the top support when placed against a structure shorter than the ladder. Set ladders on firm footing and tie them off where possible. Use both hands and face the ladder when climbing up or down. Keep hands free of tools or materials when on the ladder. Be sure to open a stepladder all the way and lock the spreaders in place. Never use a stepladder as a straight ladder. Do not stand on the top cap or rung of a stepladder. Do not leave tools or materials on the top of a stepladder. Scaffolding. All workers must have scaffold training arranged by their employers. Guardrails are required when workers are on platforms 10 feet or higher. Personal fall arrest systems could be used at heights of 10 feet or more. It must be used when the scaffold platform is less than 18 inches wide, or if guardrails are less than 36 inches high, or if a single or 2-point suspension scaffold is being used. A free fall from a scaffold when using a fall arrest system is limited to 6 feet. The anchor support for a personal fall arrest system must be able to support 5,000 pounds for each worker attached to it. The platform must completely cover the scaffold work area. If planks are used for the platform, there must not be more than a 1-inch gap between planks. If planks are to be overlapped, they must overlap a scaffold support piece by at least 6 inches, but not more than 12. If it's more than 12, it will become a tripping hazard. Legs, posts, frames, poles, and uprights must be on base plates or on a firm foundation. If caster wheels are used, they must be able to be locked in place for stationary work. Toe boards must be installed on all open sides of the scaffold platform when they are located more than 10 feet high. Safe work practices for scaffolding. Never extend your body over the edge of a platform or guardrail. Keep both feet on the platform surface at all times. Always keep at least 3 points of contact when climbing scaffolding. Keep all scaffold walkways and platforms clear of tools and other materials. Remove snow or other slippery material from scaffolding before working on it. And always stay at least 10 feet away from energized power lines. Use a ladder or stairs to access scaffold when there is more than 2 feet above or below the access point. Do not use the cross braces to climb onto the scaffold or go to another level of the scaffolding. Make sure that the scaffolding can bear its own weight, as well as 4 times the maximum load on it. Do not work on scaffolding located outside when there are high winds or storms in the area. Aerial lifts. Aerial lifts have replaced ladders and scaffolding on many residential job sites due to their mobility and flexibility. Many workers are injured or killed on aerial lifts each year. Only trained and authorized persons are allowed to operate an aerial lift. Employers are required to retrain workers who they observe operating an aerial lift improperly. Tool safety. Always read the owner's manual. Use the right tool for the right job. Use power tools only after you've received proper instruction on how to safely use them. Use tools only for their intended purpose. Make sure corded power tools are properly grounded. Carry sharp edge or pointed tools in tool pouches and not in clothing pockets. Don't leave tools on any overhead workspace or structure where they could fall. Make sure that tools used on energized electrical equipment are non-conductive and have the proper voltage rating. Safety data sheets. An SDS informs electricians of a material's physical properties as well as the effects on health that may make the material dangerous to handle. SDSs are required to be present in a user-friendly 16-section format. Employers must keep SDSs up to date and keep them readily accessible so that employees can access them quickly when they are needed. Electrical safety rules. Install all electrical wiring according to the NEC. Work with a buddy. Avoid working alone. Always turn off and lock it out before working on any electrical circuits or equipment. Never cut off the grounding prong from a 3-prong plug on any power extension cord or from a power cord to any piece of equipment. Assume all electrical equipment to be live and treated as such. Do not defeat the purpose of any safety devices such as fuses or circuit breakers. Clean up all wiring debris at the end of each workday, or more often if it presents a safety hazard. The fire triangle. So the fire triangle needs 3 pieces. You need fuel, which is any material that can burn, heat, which raises fuel to an ignition temperature, and oxygen, which is required to sustain combustion. By removing any one of these fire triangle components, it will extinguish the fire. So if you remove the fuel, it'll go out. If you remove the heat, it'll go out. If you remove the oxygen, it'll go out. So these are the classes of typical residential fires. A class A, so fires that occur in ordinary combustible materials such as wood, rags, and papers. Class B, they're fires that occur with flammable liquids such as gasoline, oil, grease, paints, and thinners. Class C are fires that occur in or near electrical equipment such as motors, switchboards, and electrical wiring. Class D fires are not typical in residential wiring. Class D fires occur with combustible metals. So here's the symbols that you'll see. So Class A is green, it's ordinary combustibles. Class B, flammable liquids and gases. Class C, electrical equipment. And Class D, the combustible metals. So here's, to fight these fires, there's different types of fire extinguishers. So we have pressurized water, carbon dioxide, dry chemical, and foam. And you can see carbon dioxide and dry chemical are used for electrical fires. The acronym PASS can be used as a guide on how to operate a fire extinguisher. P is to remind you to pull the pin at the top of the extinguisher and allow the handle to be squeezed. A is to remind you to aim the nozzle of the fire extinguisher at the base of the fire. S is to remind you to squeeze the handle to discharge the fire extinguisher from a distance of 6 to 8 feet. The second S is to remind you to sweep the nozzle back and forth at the base of the fire until it is extinguished. And that's it for today.